Hello, algebra students, and welcome to the lesson on literal equations. At this point, you guys are equation solving experts, so it's time to make these equations even more fun by looking at something called a literal equation. Literal equations, think of the word literature. Literature is reading, it's lots of words, lots of letters. Literal equations is that same idea as lots of letters. It's going to be equations that have multiple variables in them. So instead of equations we're used to, like x plus 3 equals 5, equations with only one variable and you're solving for that one variable, an equation like a plus b equals c is an example of a literal equation because it's an equation that has multiple variables. You've seen literal equations before, we just didn't call them that. We called them formulas. So when you think about things like A equals L times W, area equals length times base, that's a formula to find area, but it's also a literal equation because it's an equation with multiple variables. So there are a lot of different formulas we've looked at. This relates back to those formulas, and if I had asked you to solve that formula for a different letter, a different variable, that's what we're doing in these notes. So when we talk about solving literal equations, I want to relate back to what you already know about solving equations. If I had given you an equation like this, if you haven't already done the notes, you could pause the video now and solve it yourself. Or maybe you're just so fast you've already solved it in your head. But in order to solve this, we've always said you find your variable, and your goal is to get that variable by itself. So we would want to get rid of the plus 3. We do that with a minus 3. We also, whatever you do on one side, we would do on the other. So we could say x, 3 minus 3 is 0, so we've used the words it cancels out, and we get x equals 5 minus 3, which is 2. The main thing I want to emphasize at this point is in order to solve that equation, we had to do the opposite. We had to do the opposite of a plus 3, which was a minus 3, and we did it on both sides to help us solve that equation. That idea of doing the opposite is a super important part for when you talk about solving literal equations. If I asked you to solve this equation for A, just like before we said we would need to cancel that plus 3 to get x by itself, in order to solve for A, we need to cancel the plus b. Also like before, in order to get rid of the plus 3, we subtracted 3 because subtracting is the opposite of adding. Over here, to get rid of the plus b, we need to do the opposite, which would be minus b to get rid of our b. Also like what you did before, we were going to write it on both sides. So if I'm writing minus b here, I'm going to write it over here. Also like what you've done before, when we do that, b minus b gives us 0. It cancels out, and we're left with a. The part where it's different is over here we had two numbers. You can subtract 5 minus 3. You can say 5 minus 3 is 2. With the literal equation, we've got c minus b. You can't subtract letters. It's not the same thing as this. So this is where it's different because we cannot do c minus b. Our answer is going to be exactly what we just said. A equals c minus b. Instead of doing the math, I'm just copying exactly what it says. And just like that, we've solved it. Solving means getting the variable all by itself, and we did that. It says A equals our answer. I really want to emphasize, despite the fact that literal equations are going to look so different from what you're used to, a lot of the steps are the same, which is why I kept going back to what you guys already know, right? In order to solve, we're doing the opposite. In order to solve, we're doing the opposite of adding and subtracting. The only difference is going to be what these answers look like. The answers are going to look weird because we're used to it equaling a number. Since literal equations have multiple variables, our answer is going to have multiple variables in it as well. There's a couple more of these comparisons ones that we'll do together. If you have not already done the notes, if you want to pause after each problem and try it on your own and then check by pressing play again, you can always do that too if you've already looked at the notes, so this will be just a nice explanation to go with it. The other comparison ones we have are x over 4 equals 6 And A divided by B equals C. If you want at this time to pause the video, solve this first one. This should be the review one. And then use what you're doing over here to help you figure out how you would solve this literal equation. And pause. And we're back. So if you were solving this equation, we've talked about in order to solve, you could do the opposite. Some people like to put this over 1 and cross multiply and get x equals 4 times 6, which is 24. Other people like to just go in and say we can multiply both sides by 4 to eliminate those, and you get x equals 6 times 4, which is 24. Either way, the important part is we are using multiplication. When you come over to this one, in order to solve this one, you would do the same thing. If you were one of the people thinking, let's put it over 1 and cross multiply, you can do that same thing with the literal equation. You can change this to be C over 1 and then cross multiply. We do A times 1, that gives us A. And if we do B times C, you could write B times C like that, or with a little multiplication x if you wanted to, or parentheses if you wanted to, but the most common way you're going to see it is BC. When we've talked about things like 2x, that means multiplication, and you've got a number next to a variable. Same idea here. If you write BC, that means B times C. Now, something I probably should have done for this problem that's written on the notes but not on my board right now is I need to tell you what to solve for. So for this equation, we did solve for A. Even if we weren't solving for A, maybe if we wanted to solve for B instead, a good step is to get rid of all your fractions first, just like we would do with these equations, get rid of the fraction first. That way you're left with an easier equation to solve. So if we wanted to solve for B, then we could do another step to solve. That actually leads us nicely into this next one, which looks kind of like this one. That next one, I want to compare 5x equals 30 with AB equals C. And this time I am going to tell you we are, again, solving for A. Again, if you want to pause the video right now, solve this one, see what you did for this one to help you solve this one, you can. Okay. You've paused. We can resume. So for this first one, we know at this point that this means multiplication. So to solve, we're doing the opposite, which is dividing. You would have divided both sides by 5, and you get x equals 6. For this one here, similar to that last problem we were looking at, we've got AB. That means A times B. So in order to get A by itself, we need to get rid of B. And because this is multiplication, we want to do the opposite, which would be division. Now, sometimes when it comes to these ones with dividing, I'll see students do something weird, like they might write AB, they might write A, they might write B. Keep in mind always what you're trying to solve for. So I've been writing arrows above what I'm trying to solve for. That's helped some students in the past. That helps you focus on, okay, I want A by itself. Then if you ask yourself, what do I need to get rid of if I want A by itself? It helps you figure out you want to get rid of B. So you should be dividing by B. If you divide by A, then you're canceling out the A's. We don't want to do that. We want to leave A there and get rid of everything else. So I'm going to divide by B. Also on my other side. When I do that, B divided by B cancels out, leaving us with our A. On our other side, C divided by B. Those are variables. I can't divide those. There's nothing we can do except copy exactly what we see. So C divided by B. I wanted to solve for A. That's my final answer. So we're done. These are all examples of one-step literal equations. So notice each time there was one thing I had to do. Just like when we were learning how to solve the nice equations with numbers. We started with one-step equations and then we built up on it. These are that same idea. So there's one last one to look at. We've got, what was it? 3x minus 7 equals 2. versus AB minus C equals D. Looking at the nice two-step equation with numbers, one of the questions I was asking you guys a lot when you were learning these is, where do we start? And you always said we would start with which number? Yes, the 7. Because the 7 is the constant. That constant is that number that doesn't have the variable. It's the number that's either being added or subtracted. So we always said if we want to solve for x, we would start with our constant, which is that minus 7. We solve by adding 7, which gives us 0 here, and we get 3x equals 9. Once we've gotten rid of our constant, then the next step would be get rid of the, do you remember what it's called? Starts with a C. Coefficient. We get rid of our coefficient by dividing both sides by 3, which leaves us with x equals 3. That's the review one. What I want to emphasize for that first one is the order we did it in. We got rid of our constant first, that number that's not with the variable we're trying to solve for. And then after that, we got rid of the number with the variable. We got rid of the coefficient. Idea is the same for literal equations. If I want to, I didn't tell you again. If I want to solve for A is right here. There's two things on the same side as A. There's a B and there's a C. If you're trying to solve for A, which variable would we want to start with? Hopefully you're currently yelling at the video, C, start with C. And you're right. Just like 7 here was our constant, C is our constant because it's the variable not with A. So that's going to be where we start. Also, just like this other one. If I want to get rid of the minus C, doing the opposite. Opposite of subtraction is addition. So I can come in and add C on both sides. When I do that, the negative C plus C gives us 0. So we're left with AB equals, over here, what do you think I'm going to write? D plus C. The difference for this literal equation compared to the other ones we were looking at is we're not done yet. We want to solve for A. A isn't by itself yet. There's still one last step to do. If I want to solve for A, I need to get rid of B. And in order to do that, well, this is multiplication, so we need to do the opposite, which would be division. So I need to divide by B. When you go to divide by B, just like always, we're going to do it on both sides. It's important over here, this is representing an amount, just like 9. So we want to divide that entire side by B. Sometimes students will just put like that division under one variable. This means something different than this. So we are dividing that entire quantity here by 3. We're dividing that entire quantity by B. I say all that to say make sure your division sign goes across the entire amount. After we do that, B divided by B cancels out. We get A equals, this is a bunch of letters, it's a bunch of variables. We can't do any of that math. So A just equals this beautiful fraction, D plus C divided by B. And ta-da! That's solving literal equations. The rest of the ones in the examples are some more like this that are two-step. The only difference between these and those is those have some numbers mixed in. Just be careful when you're solving an equation with numbers and multiple variables. So for example, bonus problem. So for example, if I were to give you something like 2a plus b equals 3, and I asked you, we'll mix it up this time, solve for b. If we want to solve for b, it means I need to get rid of the 2a. In order to get rid of the 2a, instead of adding 2a, I'm going to subtract 2a. Whatever we do on one side, we do on the other. On the left side, 2a minus 2a cancels out. and we get b equals, take a moment and figure out what you would write here. Have you taken your moment? Okay. The reason I say be careful with these literal equations that have numbers and variables mixed in is a lot of students see this and they say, oh, 1a. There's a problem with that. Do you know what the problem is? The problem is these are not like terms. This is a number and this is a variable. So going back to what we learned in pre-algebra with combining like terms, you can't combine things if they don't have the same variable. So I say all that to say, we cannot subtract these because this would need like an A right there in order to subtract them. So since we can't subtract them, just like what you were doing earlier, we write everything we see. We write 3 minus 2a. So the only thing I have to add before you try the other ones in the notes and on the practice is be careful with those numbers. Make sure if you're subtracting something, they are actually like terms. We include a lot of examples for literal equations because I know they're different, and to be honest, it can look kind of crazy. Like we've completely taken the numbers out of math and here, do some math with letters. But the real emphasis I want to put on these notes is you're using all the same steps you're already used to using for equations. And based on the homework you guys have turned in, you are actually equation solving experts. So all of those takeaways you've had from those notes on solving equations, you're using them here. Just be real careful when you're solving these literal equations that you're doing the opposite operation. So if I give you something like this and I ask you to solve for b, we can't subtract because this isn't addition, it's multiplication. The opposite would be division. So just be careful with those opposites. Good luck with this lesson. You all are doing so great. I miss your faces so much. I hope to hear from you guys during the office hours. Don't forget about those if you're having trouble or just freaked out by all the letters, but I promise you it'll be okay. And you will get it. It'll all be good. Good night for now. Bye.